Now that we've looked over these compounds, let's compare the flammability of ethanol, ethanal, propanone, and ethanoic acid. Put 1 to 2 milliliters of each of these liquids in a watch glass. Try to ignite the sample. Let's see what happens to these compounds. Ethanol is flammable. Doing the same test with ethanol, we find that it is also flammable. The third compound, propanone, turns out to be also flammable. What about ethanoic acid? Ethanoic acid is not flammable. We can't do this with 40% formaldehyde since there's too much water in the sample. All compounds except the carboxylic acids are flammable. How can we explain this? Carboxylic acids are fully oxygenated and will not burn. Alcohols are only partly oxygenated and will burn in air. Because of the flammability of alcohols, precautions must be taken in storing and handling them. Refill alcohol burners only after the glass container has cooled down. Alcohol vapor is heavier than air and tends to spread over the surface of the table rather than diffuse quickly into the surrounding air. Let us again compare the reactivity of ethanol, ethanal, propanone, and ethanoic acid, this time with an oxidizing agent. To 3 milliliters of each sample, add 3 milliliters of potassium dichromate acidified with sulfuric acid. What are the results? Upon addition of acidified potassium dichromate, the ethanol turns green. The same thing happens to ethanal, which also turns into a dark green color. There is no immediate change in the color of propanone after acidified potassium dichromate is added. Upon standing, it darkens a little. There is no visible reaction with ethanoic acid. The solution remains orange. The alcohol and aldehyde solutions turn green. This indicates the formation of chromic ions, which give this distinct color. The color change is instantaneous, which shows that alcohols and aldehydes are oxidized rapidly. They are easily oxidized by dichromate in acid solution. The slight darkening in color of the ketone suggests that a reaction has also occurred. On standing, the solution eventually turns green. This slow reaction can be hastened by heating. The product is not a ketone. No reaction takes place for the carboxylic acid, even with the application of heat. To summarize, propanone turns green, ethanoic acid, no change. These results tell us of a relationship between alcohols, aldehydes, ketones, and carboxylic acids. Alcohols are oxidized to aldehydes or ketones. Aldehydes are readily oxidized to carboxylic acids. Ketones are very slowly oxidized to lower acids. The symbol O above the arrow indicates that an oxidation reaction takes place. Consider the series of oxidation reactions that methanol undergoes. Methanol is oxidized progressively to methanol, then to the corresponding acid, methanoic acid or formic acid. Formic acid reacts readily with the oxidizing agent acidified dichromate and decomposes into carbon dioxide and water. All the other carboxylic acids do not react with oxidizing agents.